Hello, good evening. My name's Chris. I work at Pearson, and in the first of this battle royale, I'm here to talk about us running Kubernetes in production. The sheep image is something I used at a previous presentation, which really kind of reflects what we're doing inside Pearson. We are the kind of black sheep of it all. Out there on the side doing crazy things with containers and trying to get services into production whilst the rest of the business sorts out their Windows 2003 issues. So a little bit about me. For some of the people that I know very well here, prior to Pearson, I spent a lot of time at Rackspace. And Rackspace was a very formative time where I found that although I loved the technical stuff, I really wasn't a coder. I was much better at PowerPoint, and that naturally led me to leadership rather than engineering. So now I've learned to get my kicks from watching other people do great things with tech rather than doing it myself. That is also a very nice way of caveating, I have no idea beyond the content of these slides. Live tweet questions to my team, and they'll sort out the answers that you need. So, a bit about my work. Pearson are an old company, established in 1844. And they started out as a construction company. They built the Woolwich Tunnel. And over the years, they've changed from construction to publishing. They had some crazy identity crisis in the 90s where they bought the production rights to Baywatch and Madden Tussauds. Apparently that was a good asset. And then we moved towards education wholesale, and then from textbook type education to digital education. And how do we start to empower the students of the future to learn through online methods with really strong online experiences to support whatever they can do in a classroom. It's a really good mission because it's full of moral fibre. At the end of the day, if we make a difference, we make education a little bit better. And with our global reach, that's not just to some well-to-do people in West London. That's people in Africa and the subcontinent who really need a good quality of education to compete in a global market. So this is all about ISBN to FQDN. And we've really been set out from the very get-go. In fact, I was here about 9 or 10 months ago talking about us starting this project and what it had taken to even get people to listen and get it off the ground. So 10 months on, we've been continuing to challenge stuff and push the barriers. And here's an update of where we've got to. So in previous talks, I've talked about this project called Project Bitesize. Project Bitesize was designed to answer the question in Pearson of how do we eat the elephant, which one bite at a time. And what we're trying to do here is we're trying to build a capability for developers in Pearson that really stops them caring about a lot of the things they currently have lots of very strong opinions about, like what IAM role to using Amazon and how they should configure their VPC. Our job is to provide an awesome platform experience. And when we came into this, because I represent internal grey enterprise IT, we were dismissed with the, you probably can't spell AWS. And what we tried to do there is say, well, you can't then bring a cloud and VM solution to a cloud and VM party if you want to be the interesting people. So we came in with, okay, well, what about containers? Surely no one's doing that yet. And the answer was no, they weren't, but equally, not many of them were very ready for containers. So it's been that story of us building a platform whilst they develop maturity to adopt the things that we're making. And what we're doing here is we're combining the concept of a standardized delivery pipeline with a container runtime environment. So you don't just get the ability to do a deployment via Kubernetes, you get that baked into your own pipeline, so you're doing everything from commit and branching all the way through to a production artifact underpinned by the automation that we're delivering. So whilst we're talking about Kubernetes tonight, our platform is a smorgasbord of open source tools that we've stitched together to try and build the best possible experience for developers. And we try to be cloud agnostic in how we do that. So for example, we lay our platform down using Terraform. It's not the simplest solution, but it will give us a route to get this deployed onto AWS, Azure, OpenStack, Google, so that when we think about taking education to a global market, we haven't got to worry about the fact that AWS Beijing is a little bit flaky, we can use Azure in Shanghai, which has got a much more proven track record. We can take things like OpenStack to very remote parts of the world where there isn't a public cloud choice and we need something from a privacy perspective. So we know we've taken on tech debt there because we can't use fancy things like RDS and Aurora globally. But the payoff is that we've got much more freedom around where we place workload from a commercial perspective, but also how we choose to deploy in a global market. So I've got a couple of detailed slides just to give you a view of the level of maturity and where we're at with our architecture. I have validated these with my lead engineer and he's happy that they are borderline accurate. We do all of our work in PowerPoint. There's no such thing as Visio or Lucid charts. So we use Kubernetes in a HA model. So this is still within a single cloud region, but we deploy our minion hosts across multiple availability zones, and we distribute the services equally across those availability zones so we can take AZ level outages and still contain and deliver services. We have split our platform into what we call the ingress load balancing front end and the private back end. That's a point of debate in the team right now, but it is what it is right as we stand. And that's fronted by a really straightforward ELB just to kind of round robin some traffic across those ingress front ends. All the SSL termination, all the complex load balancing is handled by those ingress layers. And they are completely handled like cattle. We pull the config from console and vault as a combination of key value and secret store. And that also does all of our SSL cert management. So when we spawn a new ingress controller, it pulls in all the SSL certs for all the different services that we're running. It's effectively a zero-touch load balancing solution across the front end. So as we provision new namespaces and new customers, because we provision the respective spaces in Vault and Console, it's a simple matter of dropping the new certs in for that ingress to be detected and start to build an HTTPS endpoint for a new app. Flannel connects the PaaS level networking together. It's, again, a conversation in the team right now around what's our chosen overlay on top of underlay networking solution. Calico's in the mix as well. We're looking at some commercial options, but right now Flannel seems to do most of what we need. And on that back end then, it's really default open source Kubernetes stuff. We're not doing anything too special. We have a master which runs distributed etcd across a number of hosts, and they then build the replication controllers to then spawn the pods. We do a one-to-one mapping container to pod, and we'll talk in the next slide about how all those different images get built. We provide some of the basic services, so if you want a Linux-based image, or if you want a PHP or a Java or a Node.js image, we provide those. And using the Docker layering concept, we can allow people to build their own application artifacts on top of that, but it's all held in one central Docker registry. So a little bit about the standard delivery pipeline. So we've abstracted all the kind of controls the developer needs into 3 build manifests: application.yaml, build.yaml, and environments.yaml. The developer defines the environment they need based on a set of known fields and levers they can pull. And we use that data to then configure Jenkins. So Jenkins isn't a monolithic gateway in our architecture. It's treated like cattle as well. So if we lose a Jenkins container, it respawns and it pulls its config from those build manifests and rebuilds the pipeline and picks up where it left off. So the idea here is that when your environment definition says, for example, I then need these stateless services and then this persistent service, Jenkins knows that it goes to Kubernetes to get the stateless services, it builds the replication controllers, it maps the right Docker image, and then builds out the number of replicas that you need. And if it needs a stateful service, because right now we haven't enabled the stateful parts in Kubernetes, we use a workflow automation tool called StackStorm. Their first London meetup was on Tuesday. It's awesome. I suggest you go along and check it out. Sorry, DOXLON, but this is a community model here. And that spawns off a CloudFormation template to build a 3-node Cassandra cluster or whatever else we need. But we go one step further. Because StackStorm joins multiple tools together into an end-to-end workflow, we also take the connection string information and populate that into console. and we take the database passwords and populate those into Vault. So when a developer gets handed over the environment, they've never typed in the password, they don't know the connection string. As long as they've got the environment variables defined that map to the console stuff, then they're going to make that database connection. And we can do that per region. So as we move to a global software model, we can localize PII and database connections to an individual region, but entertain a largely global code base. It's also worth pointing out, we're trying to do the kind of DevSecOps and DevQA ops piece as well. We've made it possible for our partner functions to load their own test suites into that pipeline. So they pull from a separate Git repo. So at the point of instantiating a pipeline, we can pull down whatever AppSec tests they want to do. And because all this stuff is version controlled in files, any group can take this stuff and go build a copy of their production environment on a separate cluster or on the same cluster. Which means they can run a pen test of destruction, we can run a 48-hour QA soak if we need to, without really thinking about disrupting production traffic. When we build complex testing pipelines with dependencies, the intent is that someone can book the stage version of their software, but then all their dependent services can be cloned from their production copies, and we get a valid end-to-end production test before we move something into our prod versions. We try and dog food this mentality within our platform code as well. So it's an official announcement. As of today, we did our first zero downtime release of our Kubernetes environment. We effectively A/B it. The secret is that we run it across the same VPC. So we stand up 2 copies of our PaaS across the same VPC. The database services don't know the difference. We migrate etcd over, and we migrate the registry, and we copy the applications. And then we got the load balancer over the last step. So we've been about 8 weeks worth of work to get that running. Expect a blog post from us soon, but that was something we finally got done today with no customer disruption. Yes. I'd love to take the credit, but there's some people still working in the office that did it. Cheers, guys. So current status. This is my 1-year-old, and we feel a little bit like my 1-year-old. He's quite capable of walking, but he could faceplant into a wall with no notice. Every outage we have is a learning outcome. We're still finding that best effort in the Kubernetes scheduler isn't always best effort. But we are making lots of good progress. We've got an application now live in 2 regions. We have production services in US East and Singapore for Amazon. Second app is due live in December. We've got a roadmap for 50 apps by July 2017, so the obligatory I'm hiring definitely applies. We're also seeing about 25 to 50% cost reduction in cloud running costs when we move an app like for like from where it currently lives in Amazon to our platform. And from a user perspective, indicatives say that we'll have about 200,000 global learners depending on us by the end of Q1 17. So we're definitely hiring ops people as well. We're seeing more and more releases. So our anchor partner, the people that kind of trust us to go with this from day one, have had almost 400% more releases since they cut the platform over from the 6 months before. And it's actually driving culture change. So when I talked back in the start of this, I hoped that we could start to change the engagement we have with developers. It's really happening. We're being seen as credible partners versus boring enterprise IT folk. And it's changing the dynamic about how we can influence their app design and what they do to introduce stability. So why Kubernetes? Because that's why we're here. We're talking about Kubernetes, not Pearson, right? Well, reason number one, a lot of people will say it's complex. And I think it is hard to get going on Kubernetes. But what we found and what we hypothesized at the start was that upfront complexity pays off in capability long term. It has an inordinate amount of runway to go build and deploy production services. You just need to get yourself over the hump. Reason number two, it's a low-risk open source community model. I'm very deliberately not here to badmouth other open source projects. But if we look at the way this has been structured and the way that Google are managing the program, it meets our open source criteria, which is Apache 2, strong anchor sponsors, sustainable contribution models, a largely non-commercial motivation other than you should buy Kubernetes as a service from us. High development activity, quarterly release cadence, and established implementation patterns. We weren't trying to find this stuff out for the first time. And reason number three is Google. They might still be moving away from Borg, but this is what they're using to try and scale their own internal systems. And Google have got some of the smartest engineers going. We'd love to stand on their shoulders. So it's not all roses. Where are we going next? So we're taking this to now multi-region deployments. Rather than having 2 autonomous regions, how do we have one deployment endpoint that can orchestrate across multiple regions? We're watching the work around Kubernetes, their kind of federated model, with a lot of interest. We want to containerize databases, not all of them, but some of them. So Volume Manager and Pet Sets, we're working with the guys from JetStack. I don't know if they're here tonight or not. Hello. To kind of understand what that looks like and what a really solid production reference architecture looks like. Zero downtime platform releases is now done, not almost done. And things like metadata frameworks. How do we start to have information about services available to other services so they can almost build their own automation as they go when they have understanding of their dependencies? And security, just because it's always security. Where are we struggling? We need the early access features that Kubernetes are turning out every 3 months in GA straight away. The rate that we're trying to adopt the new capabilities offsets tech debt that we'd otherwise own ourselves. So the sooner this stuff is production grade, the sooner we will start to consume it. Upgrades, see above. They are working on their in-situ upgrade from 1.3 to 1.4 to 1.5. It could still be easier. kubedns, we have a motto in ops, which is step 1, check kubedns. Step 2, check it again. It is a beast to tune it properly, and it is probably the #1 damaging factor for application performance when we hit an unexpected load spike. From a networking perspective, there's not enough choice, I don't think, right now in the kind of container network orchestration layer, nor is there enough differentiation between the people that are already there. I'd like to have more polarized choices and a wider array of features. And security, just because security. So to close it, we're here doing this kind of battle royale style thing. Pearson have chosen this direction with Kubernetes because it's what works for us. We're going to hear some really cool stories from Mesos. I would have hoped we heard something from Swarm, but that probably says volumes. But really, can't we all just get along? This is about what works for an individual company. It's not about a holy war on tooling. And the more people that are problem solving in this space in independent communities, the stronger the output will be as a whole. Thank you.